Hello and welcome once again. Yesterday in the video that I made about computer control boards and modules, there was a technique that I did not mention, I forgot to mention, and that is I spoke about vibration. These pins on these chips are very sensitive, and also sometimes they don't make contact, especially through vibration. Now these are soldered by a machine, but sometimes still they don't make contact. This is not hand solder until I repair it or we do other things to it. So the technique is to take something, usually a pick. We take the pick. These are, as you can see, these are the pins. Okay, we take the pins and we go along them like this, making sure that they don't move. Let's try this one. Here are the pads. This is how it makes contact. We go through here. Now, if anyone is intermittent or making a small contact, when I go along with the pick, with this pick, it'll move and it'll jump off the pad. This is the best way that I've used to make sure that these chips are soldered correctly. Again, it doesn't matter if it's four or 200 pins. This is the best method for any chip. See? If it moves, it jumps up, it wasn't soldered correctly. Now, to get to our business at hand over here. Now, I spoke about it yesterday about opens and shorts. Okay, I chose this one over here. Let me zoom out so you can understand what's going on. I chose this one over here because it's pretty simple up to this point. This is the computer module. Now, opens and shorts. Now we have a regular fuse. Whenever you see ECM fuse, that's the fuse going to the computer. Again, the computer is called the PCM. However, this is called the ECM. Still, same thing. Now, so current flows. This is the connector, the terminal over here. This is a connector through a pink wire. And through a connector through pin 19. Of these many connectors through this PCM board, computer module. Now, this one over here is the same thing, as you can see, this one and this one. So how many voltages are going through this? At least 3. One is going through here, 12 volts. Another one through pin 20. Another one through pin 57. And pin 19. Ignition voltage, positive voltage, battery, and battery positive voltages. So 3 different pins are getting 12 volts for. Look at all the circuitry that's in hand that it has to deal with. Anyway, now, let's take opens. Simple. Now, before the open, we always measure battery voltage, which means it's 12 volts. After the open, it's going to be 0 volts. Why? Because it's not connected to battery anymore. Now, let's say C2 is a connector. This connector is open. It's not tight. Okay? 12 volts over here. How much should I measure at the battery? 12 at the battery point of the fuse, 12 volts. How much should I measure at the other one? If you said 0 volts, that's not right. We measure still 12 volts. This is not a blown fuse. We go over here to the connector itself. The terminal is 12 volts. But when we go over here, if we're able to go through this pink wire, we have 0 volts over here. So if we were able to get through C1 or pin 19, which is hard to get access to, we have 12 volts here, 12 volts here, but 0 volts over here. That means somewhere along this line, this connector or this connector, we're not making good contact. Or, of course, the pink wire broke on us. If the pink wire broke on us, that means, look at it this way. C2 would be 12 volts over here, but this one, pin 9, would be 0 volts. So it depends where the break is. Okay? Same thing over here. This orange wire broke on us. When we go over here, this terminal, A8, is 12 volts. Right? We go over here, 12 volts. We come over here, if we're able to get access to this, it is 0 volts. That means we lost it somewhere. What's between here and here? Only a wire, an orange wire. Same thing applies here. Let's take a more severe case, a short. How do you measure shorts? First of all, I have a voltmeter here, as you can see, simple. I put on volts, 20 volts. This is the symbol for DC. Always I put the black one will be on the ground. This is the ground of it, the physical ground. This is the red one. This is that I move around. Okay? I go to the top, one side of the fuse. It measures 12 volts. I go to the other side, it measures 0 volts with the same probe. What does that mean? Obviously, I have no connection to the battery when I went to the other side. That means obviously this was blown. So this fuse was blown. So now the question is there a short? Referring to this fuse. This is 50 amps. It's a different type. The maxi fuses, but still the point is the same. Now, did this blow because of excessive current? Did it blow because of a voltage spike? These fuses, this is rated at 32 volts. 32 volts at 50 amps. I can have a voltage spike that's very high and blow that fuse. But chances are I have a short along here. Now, what's between here and here? This is the tough part. A wire, a connector, a wire, a connector, and the board itself, the PCM board itself. The problem is this is hundreds of dollars. This wire is cheap. So what do? What 100% of the mechanics will take a fuse, put another fuse in there. Excuse me. We'll take another fuse and put another fuse in there. Of course, that will blow out. Will blow also. What do? Here's the voltmeter. Excuse me 1 minute. Here's the voltmeter. The same one that we use voltage for. We measure from here to ground ohms. I put this on ohms. Which scale on ohms? The smallest one. This is ohm symbol. This is the smallest one. The smallest one. This is reading open or out of limit when you see this. Anyway, I'm going to take this probe the same way we measured voltage. Before I change, put a new replacement fuse. Never put fuses after fuses. First thing is, when you see a blown fuse, measure ohms. That means somehow from here to here, something pulled it down and something blew the fuse. You have a short here, somewhere here. Anywhere. Now, how do I do this? How do I measure shorts? Which side do I go to measure a short in resistance? First of all, you cannot go to this side. Why? This has the power. This has the 12 volts. You cannot measure ohms with power connected. Okay? Power has to be disconnected to measure ohms. So, let's go back a step. I said the first statement that I said is this is 12 volts and this side is how much? 0 volts. That alone gives you the fact which side is the side going to the short. If 12 volts is here, that means it's this side of this fuse where I'm measuring it on the fuse is connected to the battery. That means the other side is not connected to the battery. It's connected to the short, and it is safe to put my probe on the other side. That's the magic word, the other side. The fact that I measured 12 volts on this side, whatever that side was, means that this connected to battery, it's not the short. The short is on the other side. Now I'm safe to put my probe, ohms, on the other side, the one that's connected to the short. When I measure a short, I measure 2 ohms, 3 ohms, whatever it is, very low resistance. If I measure very low resistance, I have no business to put another fuse. You always measure resistance before you put a fuse in. Always. If I measure resistance and I measure high ohms in the kilo ohms or 1,000, whatever it is, anything except a dead short, I'm going to take this fuse, put a replacement fuse and put it in there. I'm safe to do so. If I measure a short, That's the first step that you do when you take out a blown fuse. You never replace fuse. I used to work with a guy, he put in 3 fuses, they all blew. What did he accomplish? Nothing. Now, you go over here and I measure ohms. Again, ohms from here to here, and I measure dead short. This is a big problem right now. Okay? Now, something is pulling this down. We call that being pulled down to ground. That means there's a dead short to ground. How do we go about it? Where can we have to be able to break the circuit somewhere to isolate that problem where the short is. Let me explain further. That short can be the actual PCM itself. That's the worst case possible, right? In the hundreds of dollars to reprogram it, that's the worst case possible. What's the best case possible? This one over here, this pink wire, broke. When it broke, guess what? It made contact with a ground, a chassis ground, any ground, because ground is all over, right? Now, I'm thinking it's either this, or the wire itself. How do I isolate that? That's a difference between hundreds of dollars and a simple wire, a simple cheap wire to the customer. How do I isolate it? Now, I look for a connector. Where can I break it off? Let's say I go over here, okay? We said we measured 12 volts here with the voltmeter. The other side was 0 volts. Fine. We made a resistance check. That was the clever thing to do because you know why? You measured 0 ohms to ground. And you did not put another fuse in to blow another fuse. Never, like I said, I stress it over and over again. Do not put fuses without measuring resistance from this point of the fuse to ground. I stress it so much. Now, excuse me. As you see over here, let's say I'm going to take C2 out. C2 is a connector with A10. I'm going to take this out. Where am I going to leave my probe to measure it short? I'm going to leave it, let's say, at this part of the fuse. Okay, all the time I'm going to leave this part of the fuse because this is where I measured 0 ohms. I took this out, right? I took this out, the short went away. What does that accomplish? Nothing. Why? When I took this connector out, I took the pink wire out. What else did I take out? I took the computer out. That leaves me in the same situation. I don't know if it's the pink wire that's touching ground. I don't know if it's pin 19. Look at all these grounds over here. Maybe pin 19 somehow is connected to ground internally and it's shorting it. Okay? Now, that's not good, right? So, what other point in my mind can I say, you know what? It's not the computer, which is the most expensive thing so far here. If you said this one, you're correct. Now, to get sometimes access to this PCM is difficult. We know that, right? But at least let me try to get the connector off. I'll go to pin 19. I'll take the connector off. Even though there's 50, 60 pins that I'm taking off with that single connector. That's okay. As long as I'm isolating, is it this or is it the line itself feeding it? Once I take off the connector that goes to this, correct? And I measure at this point. I'm still measuring. I didn't move my probe. I clamped my probe of a meter at 0 ohms over here. I took this connector out. Guess what? I still measured 0 ohms. You know why? Because this pink wire broke. And also when it broke, it touched chassis. Now I know for sure because the computer is not in the picture anymore. My problem is the line feeding the computer. That's the first case. Okay? The short is still there. Right? Let's say when I go and I take this one out, I take the connector out. Right? I take this connector out over here. And when I do that, the short is not there. If the short is not there, right, that means, you know what? This was pulling it down. So in other words, I took this out, right, and I had, again, the same sequence, and I took this one out, and the 0 ohms went away, this was pulling it down. He's the culprit. But, hold on, we're not finished yet. We're not finished yet diagnosing. There's connectors that go to this. These are all a bunch of connectors. Maybe the connector itself is shorted to something, another pin next to it. And it's not the PCM. In other words, let's say pin 19 is touching pin 18, or pin 19 is touching pin 20. That's how you always go about it. Once I take out the connector, always go to one before it and one after it to make sure that connector itself is not the problem. Because why? If the connector itself is a problem and I put another PCM board, a new one, a replacement, guess what? You just threw away money. Because that is going to stay there. That's going to stay there. What's the example? Let's go to the example over here. I'll come back to it. This is the connector over here. As you can see, this is the connector. Now, on the connector itself, the pins. This is C1. We're talking about connector C1. We were dealing with pin 19, pin 20. If we're dealing with pin 19, always go to the one next to it and the one before it. 18 and 19, make sure there's no short on the connector. This is the actual PCM. Okay, on the connector itself, on the connector, which this is, make sure if it's the connector and the computer, both. I always do both. Let's say we go measure from 0 here, ohm continuity from here to here, and from here to here, because I want to make sure nothing on the connector is shorted before I put in a new one, and I want to make sure on the computer itself. If I have the computer, let's say this is not the computer, obviously, but let's say this is the connector over here. Where was it? Oh, let's say these are the pins. I measure from this one to this one to this one, right next to it before it. Measure continuity. Make sure this is if I say the computer is shorted, I want to measure a short there on the computer. But I want to make sure the connector is not the problem. That's the main point of it. Okay? Now, I know that's a lot to absorb. Let's go back to it now. Always in that sequence. Again, we had a short. We didn't know if it's the wire itself. We didn't know if it's the PCM. And let's throw something else in. We didn't know if it's the actual connector to the PCM. Okay? You took out the connector. When you take out the connector, like I said, we measured 0 ohms over here, and it's still there. The 0 ohms are still there. That means this can be shorted, or something on the connector can be shorted also. All right? Again, another case, we measured 0 ohms over here. We opened C1, short went away. When the short went away, right, we know it's not the connector of the computer. We know it is the computer. But, like I said, just to make sure, I will still do a test on C1 on the connector itself, 19 and 18, 19 and 20, just to make sure. Obviously, hey, if the short went away, it can't be this connector. It cannot be, right? But I don't take any chances. I'll measure the PCM on this one, the pins itself, from 1918, the same thing, making sure that the short is here. Because the short went away when I took out this connector. Well, let me measure this on the actual PCM itself. It's a hard concept to understand. I know it is, but you know what? This is the correct way. You never put a replacement after a blown fuse to put another fuse in unless you measure the ohms first. First step number 1. Step number 2. What's connected to this side of the fuse that might short it to ground? Okay? That's what you ask yourself. This is how you measure it, from point here to ground with the black wire. If this is shorted, if this blew, what do I do? Same technique. I find the other side of the fuse that's not 12 volts. That's the safe way to do it. I measure from here to here, correct? And I measure 0 ohms. I'm not going to put in another fuse. Anyway, I hope that was informative. And like I said, it is complicated. Anything that has to do with computers is complicated. Anyway, please go to my channel, Joe Electronic Schematics for Auto, and my other one, Automotive Electronic Schematics by Joseph. You'll see more videos, and you'll see hands-on when I did test fuses in the fuse panels, and you'll see more understanding what I'm talking about. Thanks.